Hello friends, as today we have to design this building and apply this on seismic loads. So for the seismic load, firstly we have to model this. So we open our modeling file. This is a model of 23 stories height building. So to apply a seismic load as per IS 1893 code book, so define in the define menu load pattern. In this we have type seismic load, and here seismic. Okay, now here the code IS 1893 2002, this is the previous one. So click here, add new load, and select this and modify lateral loads. So in this, both the x and eccentricity, and we avoid these all. So for this we don't change this and this. As per the IS code, the Bangalore is situated in the second zone, so it is 0.1. okay, now by this, the soil type, it's a site type, means the and the site type is the soil type, and this type of the soil we assume that it is the medium type of soil, so we assume that it is a medium soil. Select CN. Important factor, it is a normal residential building. If it is important, then we give that 1.5, or unless we give this as 1, so it is 1. In the response spectrum reduction R, we change this as 3. We don't this is we take it as a ordinary reinforced event concrete, not a special reinforced reduction factor. Okay, so we click here this, and now we click on OK, and this is one OK. Now the seismic force is defined. Now we giving to the load combination. So for giving the load combination, go on define and this load combination pattern. This there is no, so we click on add default design. It is a concrete frame design building, so we click on this and click on OK. So it is here, you see 1.5 dead load, 1.5 dead load plus 1.5 live load. Third number is for 1.2 dead load plus 1.2 live load plus 1.2 seismic load, and this is 1.2 dead load plus 1.2 live load and minus in the negative direction. This 1.5 dead load plus 1.5 live load. This is 1.9 dead load plus 1.5 seismic load, and this one is against. Okay, so now we click on OK. So by this we define the seismic loads. So it is we only analyze the seismic load, so we don't analyze the for wind load case, because both are the lateral loads and it's happen only one time at a one load. Okay, so we go on the analyze and set the load for checking purpose. Set load case to this one. In this seismic load run, live load is 1, dead load is 1, and model is 1. So it is good for us. There is no wind load. Now click on run now to perform the structure analysis of the given model. So now wait for some time as the software analyze the building of this. as the analysis is going on, you see it is 95%, 97% going on, 100%, then it is done. Okay, now as per the given, the building is analyzed. Now we have to design this. It's going on analyze, 100% done, saving marshals. Okay, now it is totally done. I think it is done. Okay, now for the design, click on design. Now for the design, we go on concrete frame design and select view revise preferences. See, it is IS 456 and click on OK. Now for the design, concrete frame design and start design, check. Now the Etabs run this as for the seismic design. So here it is written that analysis and design section differ for 703 concrete frame. Do you want to reiterate analysis and designs? And we click on OK. Yes. It takes some time. Now the analyze is going on. It's going on, the process is going on. Now the design processes start. Software do the design for this beams. Optimize concrete auto select properties. Here this is mentioned, which is optimizing. We have give them the auto select option to take different type of beams and different type of columns, which design checking concrete elements to all over the structure. And here analyze and design section differ for 9 concrete frame. Do you want to reiterate analyze and design? So we click on yes, and then it is going on. Thus this is the process. The concrete design is going on for third trial. It's take long process for analyze and design this big type of structure. It's a 23-story structure, and we have to analyze and design for seismic forces. So it is going on. checking concrete element. Here is mentioned, it's check, and there is the concrete frame. Then we click, we want to retry analysis, we click on no. Nice, want to take, we want to select them. Yes, by this it is selected, and we know if we just select this, and by this we change the section and the going or define process and increase the size of the beams or columns. This is the process to analyze and design the seismic forces for check the deformed shape. Yes, it is going on for the dead load, seismic load, apply. Okay, this is for mode 1. Okay, step number 1. This is the process how we calculate, how we examine this. This is the display the frames. Bending moment, moment 3, apply. One thing, click on this and then press this and then click on apply. This is for dead load, this is for seismic load, apply. Okay, and this is by this method we take the all forces by this method. Okay, now click on OK. And for calculate the response spectrum method and design time history method, we go on this and click on function and click on response spectrum or time history analysis. Click on like response spectrum, then we add the new function. Click on add new function and give their response spectrum. Now it's a concrete, the damping ratio is this and function name is this or this. It is like this way. We have to calculate these all things and convert by user defined method or this. This is the process for analyze the response spectrum method or something, go for time history analysis. And this is the pop-up menu, add new function. This is the new function. By this we draw that, and in this we by this a user from file, to click on file and add new function. Then now we browse this and input our particular data of that seismic forces, and thus we calculate the seismic forces. So this is the completion of your seismic forces apply on the building. Thank you.